Today I'm going to be demoing the reaction between dilute hydrochloric acid and solid magnesium shavings. Okay, you should be able to write the chemical equation for reacting aqueous hydrochloric acid with solid magnesium, and you're going to form some sort of a product that we're going to see here in a minute. So I have already started to set this up. The purpose of this demo video is either for you to review it and relive your fun experiences in the lab, or if you were absent, so that you could see the full lab and be able to do the full lab report. So after this point, once you view this, take down all the observations, you should be able to do the full thing, which is pretty cool. In the interest of time, I've already started some stuff, measured some things out. So I've got my reaction procedure right next to me, and I've already measured out 15 milliliters of 1 molar hydrochloric acid. You'll learn what that means here in the next unit. But basically dilute hydrochloric acid into each of these test tubes. I'm going to add 15 milliliters of the same solution into the third test tube. I didn't measure this one out yet because I wanted to demonstrate a proper lab procedure for measuring out volumes of liquids accurately. And so I've got a graduated cylinder here, and I've got the solution here, and I will show you in a moment, but I'm going to add this into the graduated cylinder up to the 15 milliliter mark, but I'm looking for the bottom of the meniscus, and I'm looking at eye level. Okay, two really important things. You got to look at eye level, you got to look at the bottom of that dip. And I'll show you that in a moment. So I'm going to carefully add that hydrochloric acid. Ah, beautiful. So I added it, I looked at eye level at the bottom of that meniscus, so that dip, okay? No, I'm tilting it, but there you go. So I'm going to add that to test tube number 3. And then I'm set up with that reactant. I have already measured out my magnesium shavings, okay? So they are right here in these little weigh dishes. You can see the silver in there. I've also got my balloons ready and labeled, okay? So 1 is going to have 0.09 grams of magnesium. Number 2 is going to have 0.18 grams of magnesium, and number 3 is going to have 0.36 grams of magnesium. So we're using the same amount of hydrochloric acid to keep that variable the same, but we're adding different amounts of magnesium, okay? Doubling each time, basically. So in order to do this so that it doesn't react before I get the balloon on, you can kind of wonder what state of matter of product we're gonna make. I like to add the solid directly into the balloon. It's a little tricky, but magnesium doesn't stick too much, okay? So I'm gonna do number 1 right away. So I added that into the balloon, okay? So I'm now going to, let's see if I can get it so it's gonna show you. I'm gonna fit the balloon onto this test tube carefully so I don't get any holes, okay? And that is number 1, if you can see that. Okay, I'll do the same with number 2, so they're just all ready to go and we can compare them side by side. So number 2, so this is 0.18 grams of magnesium. That first one was 0.09 grams. So number 2. And just trying to be really careful. Of course, these balloons kind of stick. There we go. I want it over that whole lip. Found these screw cap test tubes work really well for this. Right, that's number 2, and last but not least, number 3. This is the 0.36 grams of magnesium. All right. So notice nothing's happened yet because I haven't added the magnesium to the hydrochloric acid. So I'm just getting everything set up. And fitting the balloons on is seriously the trickiest part and the easiest place to make an error. So let's see, we're gonna wanna make sure you can see the 1, 2, 3 when it goes up. All right, All right, you ready? So at this point, hopefully you would have filled out your pre-lab on page 1, and you flip it to the back side, and you're able to add in the masses for reaction 1, reaction 2, reaction 3, okay? They're listed there. They're also in the procedure, which is also posted. You'll do the calculations later, but you're getting ready to write the observations. In this case, since we're not in the lab, I'm not going to wait the full time to measure the sizes of the balloons, but I'd like you to qualitatively describe the different sizes of the balloons, okay? So for observations, it says include temperature changes and balloon size with ruler. You're just gonna describe the different sizes of the balloons, okay? So here we go. All I need to do is tip the balloon over, and the magnesium, I might need to shake it a little bit, but the magnesium should just add itself right in there. All right, there's number 1. Go, go, go. And there's number 2, maybe. Those little magnesium granules in there. Number 2. Okay, and last but not least, number 3. So I should have said you were supposed to make a prediction for which balloon you thought which would make the most product hydrogen gas. Okay, I give that to you in the pre-lab, end of the pre-lab. So make that prediction if you haven't already. Make it now before you see the reaction. But if you look up close, you can definitely see that reaction happening, right? You can see those bubbles. You can see the magnesium moving around as it reacts pretty violently with the hydrochloric acid. And this is super dilute at really low amounts of magnesium and low concentration of hydrochloric acid. So I don't know if you can see, but number 2 and 3 definitely have more vigorous bubbles going on. Number 1, you can see through it a little easier. Okay, I can see the solid magnesium a little easier in there. And if I pull these up, now granted you can't feel it, but I feel that number 1 is warm. I'd describe it as warm. It's definitely warmer than room temperature. It's warmer than what it started with. Not hot, just warm. Number 2, ooh, that's quite a bit warmer, okay? Number 2 is quite warm. I'd almost call it hot. And number 3 is definitely hot already. I don't know if you noticed, but you should comment on which one reacted faster or slower than the others. Okay? At this point, they're still going, and the balloon's still inflating. So we're gonna check back in a couple minutes to see the result. All right, we're back with our experiment, reacting hydrochloric acid with solid magnesium. And as you can see, this has actually been going for like 20 minutes. Just want to make sure it goes to completion, and I'm running out of time, so I'm not gonna wait all night. But in any event, you can definitely notice the difference in size. So this is reaction 1 with only 0.09 grams, of magnesium. Reaction 2, which is definitely still going. You can see that. If you were able to get up close, you could actually hear the bubbles that are escaping, right? But you can see the solid magnesium reacting at the bottom still quite vigorously. It was slower to get started. It didn't get quite as warm to start, but the end temperature, if you believe me, was just as hot as number 3, which got hot very quickly, expanded the balloon very fast, but is now really slowed down in its reaction rate, right? You see little tiny bubbles in there, but nothing really substantial. Whereas number 2, as you notice, is still definitely going. See how cloudy it is? Get up real close. And number 1 has totally stopped. If you can see, all the magnesium is gone. The magnesium has 100% reacted. It's back to room temperature at this point. So only 2 and 3 are going. And as I said, 3 is barely going, and there's still quite a bit of magnesium left at the bottom. 2 is still going pretty strongly, and most of the magnesium is used up. There's much less magnesium left in number 2, as there currently is in number 3. So make sure you get all those observations down for temperature that I commented on, size of the balloons, and like how fast they reacted. And you might notice something about the size between 2 and 3. Are they similar? You know, small discrepancies aren't really significant, but you can definitely notice a difference between 1, 2, and 3. Okay? So get all those observations down, and then you can start on the calculations. The slides should really help you with figuring out those calculations. All right, that's it for now.